Hello everyone. In today's session, we are going to have a discussion about this topic whose name is test bench. For understanding that what is a test bench, at first we have to just recall our two basic topics that I have already discussed in my previous videos. That what is entity, and the second topic is what is architecture. I am writing the architecture to be in short. So basically, for understanding that what is a test bench, at first we have to understand that what is an entity and what is an architecture. Let me recall a short let me give you guys a short recall about these two topics. So what we have learned in entity, that when we are giving the entity input to my compiler is making a diagram like this. Suppose I'm naming it to be OR, and this was my output. These A and B were my two inputs, and the block is giving a name like this, right? And after the architecture part, basically my OR gate is being made, where A and B. So what we have done in our previous lectures, that during the entity part, these block is being made, and from this block to this block, the architecture is making from this block to this block. So guys, as our human nature is there, that we are never satisfied. So a question arrived in our mind that, okay, this diagram has been made. So how to check that whether my compiler is giving the output according to this diagram only, or how my compiler is giving the output according to the OR gate only, or how the compiler will be giving the output if I am making the AND gate in my architecture, or if I am making any sort of a basic gate. So how my compiler is going to give the output for that. So for testing that, we are having the test bench, right? So what is happening in case of test bench? Whatever the architecture that we will obtain after writing or after making this diagram, from this diagram, we will be giving the inputs. Let's suppose I'm naming the two inputs to be X and Y, and I'm giving the output name to be C. What will be the possible inputs that I could give to my this block, so that it will be giving me, or it will be satisfying my output, or it will be satisfying my truth table for that particular gate. Let's suppose I am making a OR gate, right? So what can be my possible inputs for a OR gate? It can be 0 0, 0 1, 1 0, and 1 1. So basically we all know till this step that these 4 can be my, or these 8 can be my possible inputs that I can provide to a particular OR gate, right? So let's check that what can be my possible outputs if we are giving 0 0 to our gate. So what is basically OR gate? A plus B, right? A plus B is basically the output of my OR gate. So when I am doing A plus B, so what is happening here? 0 plus 0 is equal to 0, right? 0 plus 1 is equal to 1. 1 plus 0 is equal to 1, and 1 and 1 is equal to 1. So here we are getting the truth table for my OR gate to be 0 1 1 1 for the all possible inputs that could be provided to it. So we are satisfying this truth table for this block particularly. So in case of a test bench, we will be giving my compiler these two inputs, right? And my as a result of my these two inputs that I will be writing in my test bench, what my compiler will give? My compiler will basically give me these as a output. What my compiler will give? My compiler will give the C as a output in the as a form of a waveform. Like my compiler will give me this sort of a output in its result portion, right? After writing what? After writing the test bench. So let's check the syntax for writing my test bench. Guys, I have already written the test bench program for you to save your time, your valuable time. So let's understand it line by line, right? So for writing any sort of test bench, at first we have to define the architecture name of my test bench and then the entity name of my test bench, right? As we have already seen, for making this sort of a block, what we have to do, at first we have to describe or define my entity where I will be defining my input output ports, and in the architecture I will be telling my compiler that what is a particular block or what is a particular gate that I want to make by using those input output ports, right? So in case of test bench also, we have to provide my compiler a sort of a architecture name and then after a sort of a entity name, right? So after writing this first line, in my second line, what we have to do, in my previous videos, I have seen that whatever will be the possible input output ports in my gate that I have to define in my entity portion. But while writing a test bench, guys, for writing a test bench, we are naming or we are defining those input output ports in my signal portion, right? So in the second line, we have to define or we have to write signal and then the input output ports and then the standard logic. And initially, while defining the input output ports, we have to assign them to be 0, right? So until my second step, we are telling my compiler in the test bench that what are my ports, right? And I'm assigning 0 to it. So after that, in the third line, we are beginning my whole program, right? So I can see here that I have written utt and then colon and then entity work dot orgate port map A, B and C, right? So what is the full form of basically utt? I'm writing here for you. Utt means unit under test. So what does this term basically mean? Suppose I have already named my program in the entity part to be orgate, right? Suppose I am telling that while I was making this diagram, I have named this diagram to be OR gate in my entity portion. And I am calling this block or I am calling this block, right? I am calling this block in my test bench portion so that I could provide it my input output and test that or check that whether my compiler is giving or is there any sort of error in my program or whether my compiler is giving my desired output for that particular gate, right? So here I am basically the full form of UTT is unit under test, that my this particular diagram whose name I have given to be OR gate is under the testing part, right? And then like here I am again writing entity and then work dot OR gate. Why am I writing OR gate here? Initially, while writing the entity portion or while writing the architecture portion, I have named my program to be OR gate. So here also I am basically calling my this program, this block, or this program in my test bench portion, right? So that's why I have called here work.orgate. And then we have to understand what is basically a port map. As I have already told you guys that I am not mentioning the entity portion here again in the test bench. So how my compiler is going to understand that what are my input ports and what are my output ports? So for that sake, we are making the port map, or we are using the port map function out here. Here basically the port map function will be working as according to the sequence that we have already mentioned in my entity portion while making this diagram. Okay. And if you guys are having any issue or any problem for understanding the entity or architecture, you can very well go and check my previous videos, and if there is still some issue, you can put that up in the comment section, right? So according to that sequence only, here I will have to give my or write my port mapping. So what is happening in my port mapping? As I might have already written that A and B will be my input ports. 1 minute, I am again drawing this so that it will be more clear. Suppose till my architecture part C, A and B, right? Suppose my architecture part or in the entity part, I have defined these ports to be my input port and these port to be my output port. So there will be a sequence for that I might have written A in standard logic, B in standard logic, C out standard logic. So according to that sequence only, here when I am doing the port mapping, my compiler is also understanding that yeah, my A and B are my input ports and C is my output port. Okay. So till this line, we are in the first portion, we are basically calling my entity, and in the second portion, I am giving the port mapping of my input output ports. And then in the next line, what we can see, one thing you guys always have to remember, like while writing any sort of a test bench, that test bench will always be written inside what? Inside a process. Whenever I will be giving the input output values to my compiler, so that has always to be written under or written inside a process. Okay. So here also I have initiated my process. So for that, what I have written TB and then colon and then process. So what is the full form of TB here? The full form of TB here is test bench. I'm giving the compiler to be a keyword to be test bench as TB, and then I am initiating my process. So after writing this line, I am starting or I am beginning to give the input output values to my compiler. So what is the first possible input output value that I have checked for my compiler? That is 0 and 0. So here also I have already told you that this is known as the assign operation. You can go and check my previous videos, right? So as I have seen that my first two possible inputs can be 0, 0. That's why here also I am giving the first two possible inputs as 0 to the A and 0 to the B. So here I am giving this input to my compiler in the first line. Okay. So what next I have written? I have written here wait for 2 nanoseconds. Why I have written this line, guys? I am telling you. If I would have simply skipped the step of wait for 2 nanoseconds, I might be getting the waveform to be like this. Okay. You guys just tell me in the comment section, right? That are we able to achieve or are we able to understand any sort of a outcome after observing this sort of a wave? Or if my compiler is giving A, B, and then C. So which one is better for you guys to understand? This sort of a wave or this sort of a wave? For me or for other programmers, this is the most understanding way, or this is the most easiest way to understand. So that's why I am putting here a delay of 2 nanoseconds after the first input is taken or the first input is read by my compiler. Okay. So here I have, that's why written wait for 2 nanosecond and then go and check my second inputs. So in my second inputs, what I have seen that 0, 1 will be my, 1 minute, 0 and 1 will be my second possible input that could be provided to my OR gate. So that's why here also what I have done, I have given the A value to be 0 and B value to be 1. And then again what I have done, I have again provided a time delay for 2 nanoseconds. Okay. So similarly, in the third, or what is the third possible input that could be provided to my compiler for OR gate, that is 1 and 0, right? Here also that's why I have given the value of A to be 1 and the value of B to be 0, right? And then again I am giving a time delay for 2 nanoseconds. And what is basically the last possible input that I could provide to my OR gate? That is 1 and 1, right? So here also I have given the possible outputs to be 1 and 1, and then again wait for 2 nanoseconds. After writing or after providing these 4 possible inputs to my compiler or to my gate, what in the next line I have to do? In the next line, I have to end my process that I have initiated at first. Remember, always remember one thing, guys. In this nature or in this world, whatever the thing that is starting, right? This might be a philosophical thing, right? START. Whatever the thing that is starting, everything needs to stop at a particular time, or everything is having a ending, right? Whether it's your studies, whether it's the birth of a baby or the death of a person, whether it's your relationship, um, and doesn't matter, whatever it is, if it is having a start, then it must be having a ending, right? So here also I have to end my process TB, right? I have initiated or I have started my process, and then I have given the inputs, and then after giving all my inputs, I have stopped my process or ended my process. So after ending my process, what was the one more thing that I have started before starting my process? I have started my architecture definition also. So that thing also needs to be ended. As I have already told, everything in the world has an ending, right? So here also I have to end my architecture that I have initiated at first, right? So basically we have understood till this point, okay? And there, if there is still some issue, you guys can very well put that up in the comment section, right? So I hope you guys have understood this syntax. So let's check this practically in the compiler. For you guys, I have already written the program that I have explained you just a few seconds ago, that I don't need to mention the entity here while writing a test bench. I have written an architecture name and I have given the architecture name here. I have mentioned the input output ports in my signal. Okay. I have begin my program or begin my architecture. I have written unit unders test and called my entity name here, that is OR gate. I have given the port maps here, that A and B will be my input. Here you can see that I have provided A and B as my input and C as my output in a sequence that there at first it is A, B and C. Here also I have written the C in a sequence after writing port map that there is at first A, B and C. So my compiler is understanding that A and B are my inputs and C is my output. What I have done in the next line, I have initiated my process, or I have started my process, as I have already told that while writing a test bench, we have to always write inside it inside a process. TB means test bench and then process. And then after beginning the process, I have given whatever the four possible inputs that we could provide to my OR gate that I have already seen in that truth table. I have provided that. I have also provided 2 nanoseconds time delay after writing or after providing each input, so that we could have some square waves which will be easy to understand. And as I have already told you, whatever starts it has to end. That's why I have ended my test bench in the last, after giving the last output, right? End process test bench. And at the most last line, I have ended my architecture. Here I have given my architecture name to be behavioral, and in the last also I have written end behavioral, right? I have already saved the program, guys, and I just need to run the simulation for that. So let's check. Run simulation, run behavioral simulation. Wait for a few minutes. It might take some time. So what we can see here, we are getting some sort of these kind of a waveform. For getting a square waveform, we have to press at first zoom fit. Now after pressing zoom fit, what we can see? We can see that the square waves are coming, but they are not that much observable. So for that, what we are doing, we are zooming in, right? So after zooming in, let's go to my test bench that I have written. Okay. So what was my test bench telling for my OR gate? Like whenever I am giving 0, 0 as my input, my output should be 0, right? So let's check in the waveform as well. Whenever my A and B are 0, 0, let's check the value for C. You guys can see, no? My A is 0, my B is 0, my C is also coming as 0, right? So the first condition is satisfied. Let me mark this as okay. Okay. So let's check my second input values. What I have given in my second input value, my A will be, or my X will be 0 and my Y will be 1. And what will be the output that I will get? I will get the output as 1. So let's check that also. Right? I will be giving, let me check what I have written. Okay, 0 and second will be 1, right? So the first will be 0 and the second will be 1. You guys can see very well, no? A is 0 here, B is 1 here. So what is the output that I am getting? 1, right? So I am taking this one also. But yeah, my second condition is satisfied. So what is my third condition? In the third condition, I am seeing that I have given my first input to be 1 and I have given my second input to be 0, right? So here also, let me check that I have given my first input to be 1 and second input to be 0. Right? I have given my first input, that is A, to be 1. I have given my second input, that is B, to be 0. And what is the output in the C I am getting? The output in the C I am getting as 1. So my third statement is also verified. Now it's time for the last statement, and if this thing is verified, then I am successful in making my video, or I am successful in making my test bench, or my architecture is not having any sort of a syntax error, right? So let's check for the last output also, last input also. So what is happening in the last input? That is, both the inputs will be high. Okay, you guys can see that when I am giving both the inputs high, or when I am giving both the values and as 1 1, the output is also getting triggered, or the output is also getting 1. So what this shows? This shows that my last value is also correct, and this sums up my video that whatever the gate that I have prepared, like I have made a OR gate, that is fully correct, and that is also satisfying my truth table of my OR gate. Okay. So this is basically the working of my test bench. That what my test bench do? My test bench shows that whether I have properly made my entity or architecture. Okay. And by the help of the truth table, we are just verifying that. We are giving the input values of the truth table to the test bench, and it is giving me the output values in the form of waves, right? So I think you guys have understood till this part. And if you guys like the video, so please like, share, and subscribe, because your support is really needed, right? And in the next video, what we are going to do? In the next video, I am going to tell you guys that how to make 2:1 mux, right, by using basic gates, right? And not only we will make the architecture for this, we will also test the, or we will also check the test bench output for my 2:1 mux. So thank you for watching this video till here, guys. And if you guys have understood, or if you guys like the video, please comment down below. And if there is any issue, you can put that up in the comment section. I will very well clear that. And see you guys in the next video. Bye.